Hi ladies, today we're going to be starting our unit on periodic trends. The very first trend that we're going to be looking at today is called the atomic radius. Now if we think back to the structure of an atom, your protons and neutrons are going to be at the centermost part of the atom in an area called the nucleus. Surrounding is going to be your electrons, and they are going to be in the electron cloud. The electron cloud doesn't have a definitive outer border, therefore we need to use this method to calculate the atomic radius. We're going to have two identical atoms that are bonded together, and we're going to measure the distance from one nuclei to the other nuclei. That total distance gives you the diameter, right? If we have that, that gives us the distance of the radius. So the atomic radius is going to be half the distance between the nuclei of two identical atoms bonded together. As you can see in the visual shown below, the atomic radius overall is going to decrease in size from left to right across a period. And then from bottom to top within a group, it's also going to decrease in size as well. And I'll explain why in a little bit. If you are looking at a single row or period on the periodic table, you will notice that the atomic number is going to increase by a factor of 1 as you move from left to right. And that's because protons are added to the nucleus as your electrons are added. Now, keep in mind, elements in the same period are going to have valence electrons, or your outermost electrons, housed in the same energy level. For example, if you're an element in the third period, your valence electrons are going to be in the third energy level. That means magnesium as well as phosphorus are going to have valence electrons that are in the third energy level. So if we have two different elements in the same period and we know that their valence electrons are about the same distance away from the nucleus in both of those elements, how do we compare the atomic radius? Well, then we need to look at something known as the force of attraction. We can think of force of attraction being something like a magnet. For example, positive end of a magnet is attracted to the negative end of a magnet. Let's look at the visual on the left-hand side. You can see that the protons in the nucleus are attracted to the valence electrons of the atom. However, that force of attraction is going to increase as we are adding more protons. And that's just, think about the magnet example again. If I have a larger magnet, that's going to have a larger pull or attraction to your smaller electron. So if I were to have 4 protons, that's going to attract the electron more than if you were to only have 1 proton. This leads us to our next term, and this goes hand in hand with force of attraction. We can define the net positive charge experienced by an electron as its effective nuclear charge, and this is abbreviated by ZEFF or ZEF. So if I were to increase the number of protons inside of the nucleus, that electron is going to experience more net positive charge. So as we are increasing the force of attraction going from left to right, we're also going to increase that positive charge experienced by the electron. So as your force of attraction increases, your ZEF is going to increase. Now, if we're increasing that attraction, that's going to pull those electrons closer to the nucleus, and that means its atomic radius is going to decrease in size. So from left to right across the period, we see force of attraction increases, ZEF increases, resulting in your atomic radius decreasing. Now let's look at how atomic radius trends from bottom to top within a group. We said that elements within a period have valence electrons in that same energy level. For example, elements in period 4 have valence electrons in the 4th energy level, whereas elements in period 2 only have valence electrons in the 2nd energy level. That means that elements that are in the higher energy levels, the distance between the valence electrons and the nucleus are going to be greater. Elements in period 4 are going to have a greater distance between the protons and electrons versus elements in period 2. And so the strength and attraction between the valence electrons and the nucleus depends on this distance. So let's look at the image on that left-hand side. We have a proton and electron, and we can see that as we add more distance between these two, the force of attraction between them are going to decrease. Imagine having a magnet, and if I were to have 2 magnets next to one another, and I start increasing the distance between those 2 magnets, they're going to become less and less attracted to one another. So we can say that as distance increases, force of attraction decreases as well. And the net positive charge that's experienced experienced by the electron, the Zeph, that's going to decrease because it's further away from the protons. We can also say then, as distance decreases, so if I were to put them closer to one another, the force of attraction should increase, and the net positive charge experienced by the electron, its Zeph, should increase as well. So that means if I'm looking at elements closer to the bottom of the periodic table, it's going to have valence electrons that are further away from the nucleus. Therefore, their force of attraction is not going to be as much, its Zeph is not going to be that much, and it's not going to be able to pull those electrons in. It's not as attracted. Therefore, those are going to have a larger radius. However, as we move from bottom to the top of the group, those have elements where those valence electrons are not going to be as far away. Therefore, those are going to experience a higher force of attraction, they're going to have a higher Zeph, and they're going to pull those electrons closer to the nucleus, and therefore, they are going to have a smaller atomic radius. So we can say that as we're going from bottom to top in the group, your Zeph increases and your atomic radius is going to decrease. So as a quick review, going from left to right across the period, your force of attraction is going to increase, so your Zeph increases and your atomic radius will decrease. Going from bottom to top within a group, your force of attraction is also going to increase, its Zeph will also increase, and its atomic radius will decrease. Thank you guys for listening. I'll see you guys next time. Bye!